So after having looked at what work is in details and the calculations that you've had, let's now turn our eyes on to energy. So what is energy? What are the forms of energy? Is energy conserved or not? Is what we're going to be looking at in this short video. To begin with, we define energy as the ability or the capacity to do work. Whenever some work is to be done, whenever some objects are to be moved from one place to another, energy is always needed. So whenever there is work, there's always energy used up. So we note that work is a measure of the energy required to do a particular task. Moving an object up, running up the stairs, running of electrical devices at home, energy is always used up. So energy change is always taken to be equal to the work done. So what are some of the forms of energy that we can think of? There are very many of them, and among them we have kinetic energy, we have potential energy, we have thermal energy, we have chemical energy, we have nuclear energy, we have electrical energy, we have elastic potential energy, sound energy, and very many other forms. So we need to recall that always energy, total energy in a closed system is always a constant. In other words, energy always changes from one form to another in the course of doing a task. So that takes us to what we call the principle of conservation of energy. And how does this state? Simply says that the total energy in a closed system is always a constant. In other words, energy can neither be created nor destroyed, but simply changes from one form to another. Like in the universe, there's one major source of energy, and that is the sun, from which all the other forms of energy do come from. So in the meantime, let's try to look at some of these forms of energy and some of their conversions.
Up first is mechanical energy. As this roller coaster moves up this hill, energy is used to overcome the force of gravity. You lose energy, but the roller coaster gains potential energy. At the top of the hill, the coaster has potential energy. As the coaster moves down the hill, it now has kinetic energy, or energy of movement. So mechanical energy is the total of the potential energy plus the kinetic energy. Nuclear energy is energy stored in the nucleus of an atom. When large atoms such as uranium or plutonium are split into two smaller atoms, in a process called fission, energy is released. Nuclear power plants use this process to help create energy. Chemical energy is the energy of chemical reactions. Chemical energy of a chemical substance can be transformed to other forms of energy by a chemical reaction. A chemical reaction is one chemical substance is transformed into another. Examples of chemical energy include batteries, burning gas in a car, and fireworks. Light energy is the form of electromagnetic radiation, which means it has electric fields and magnetic fields vibrating back and forth very quickly as a wave. Visible light is the portion of this radiant energy that we can see. Examples of light energy include light bulbs, a fire, or a lamp. Sound energy is the form of energy that is associated with vibrations of matter. It is a type of wave, which means it needs an object to travel through like air or water. When you play a guitar, the strings vibrate and cause waves to travel to your ear. And finally, electrical energy is the energy that is caused by moving electric ions. Since the electric charges are moving, this is a form of kinetic energy. The faster the electric charges are moving, the more electrical energy they carry. Electrical energy powers most of the appliances and gadgets in your house. So there we go, several different types of energy. Thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe and share.